Hey everybody, it's Miss Fulmer. I'm finally recording a video for calculus. I did my other 3 classes on Sunday and got those posted late Sunday night. So I didn't leave myself time to do calculus. So my plan was to get this one recorded on Monday. But then I got the news about the rest of the school year and graduation, and I just didn't feel like doing a video. So I didn't. So here I am, Tuesday, making your video notes. We're going to keep learning some calculus because you guys all have the opportunity to take the AP exam at home. So I want you to be as prepared for that as you want to be. And the district has given us instructions to keep teaching you and for you guys to keep learning. So that's what we're going to do. I would suggest getting your notebook out and taking notes along with me, just like we would do if we were in class. And yeah, here we go. We are going to look at the chain rule for derivatives today. I'm writing on an iPad and I'm not very good at it yet, so don't judge me. Okay, the chain rule for derivatives. So suppose we have two functions f and g. If we define a new function, capital F of x, to be equal to the composition f of g of x, so basically a function within a function, then the derivative of function capital F is, so f prime of x, this is a formula to find the derivative of a function within a function, which is the chain rule. Little f prime of g of x times g prime of x. Okay, so we're going to do an example. I may go ahead and erase this so I can have the full page to do this example. You guys would be very happy that my hand is not in the way when you're writing these notes. You're welcome. Okay, so get this definition down and then we are going to do example 1. Okay, example 1, differentiate or find the derivative of r of z equals the square root of 5z minus 8. Okay, so this is a function within a function. We would say the outside function which in our definition is little f, and we're going to use z because that's the variable for this one. The outside function is the square root function. And the inside function which in our definition is g, inside function is 5z minus 8. Okay, I'm going to write the definition of the chain rule again on this screen. So within this definition, we have to know f prime and g prime, the derivative of f and the derivative of g, or the derivative of the outside function and the derivative of the inside function. So let's go ahead and find the derivative of these two functions. Before we find the derivative of this one, let's rewrite it as z to the 1/2 power, because we know how to take the derivative of something that looks like that. So when we take the derivative, it becomes 1/2 z to the negative 1/2. So the exponent comes down in front, and then we subtract 1 from the original exponent. That becomes our new exponent. Okay, let's go ahead and rewrite this. So to get this exponent to be positive, we need to move the z term to the denominator. So that's going to leave 1 in the numerator. The 2 from the 1/2 is still in the denominator. And then the z moves down to the denominator, and that makes the negative 1/2 power a positive 1/2. Okay, we could go one step further and say 2 square roots of z in the denominator. All right. Finding the derivative of g is much simpler. The derivative of 5z is just 5. And the derivative of any constant is 0. So the derivative of g is just 5. That's easy. Okay, so now we're going to use these two things that we just found to plug into the definition for the chain rule. So now that we're using the chain rule, we're back to our original function, capital R, and we're taking the derivative. So that's going to be f prime of g of z times g prime of z. Now we're just going to plug in what we have. So f prime is this 1 over 2 square roots of z, but instead of just z in here, we have g of z. So we're going to use f prime of z, this function, but instead of z, we're plugging in g of z. Okay. So we have 1 over 2 square roots of g of z, which is 5z minus 8. And then times g prime of z, which is just 5. Okay, so simplifying this, all we're doing is multiplying that 5. So this becomes 5 over 2 square roots of 5z minus 8. That's the derivative. Okay, let me show you another way to look at this. I'm going to just erase this to give myself some room. Okay, so if we have this function r of z equals 5z minus 8 to the 1/2 power, which is the same as the square root of 5z minus 8. Ooh. This is our inside function. Okay, the 1/2 power or the square root is the outside function. So when we take the derivative of this function, we get 1/2 5z minus 8 to the negative 1/2 power times 5. So the first thing we do is take the derivative of the outside function. That's the 1/2 and then the negative 1/2. And then within that is the original inside function left alone. It's the same as it was to begin with. And then the times 5 is the derivative of the inside function. So you're basically taking the derivative of the outside function and then leaving whatever's inside the same. And then after you've done that, you take the derivative of the inside function and that gets multiplied to the whole thing. All right, let's do another example. Okay, example 2. Differentiate the following functions. Okay, part A, the first one we're going to look at, f of x equals sine of 3x squared plus x. Okay, so inside function would be what's inside the sine, 3x squared plus x. And then sine is our outside function. Okay, so to take the derivative, we take the derivative of the outside function. So the derivative of sine is cosine. And then the inside function stays the same, 3x squared plus x. Then we multiply by the derivative of the inside function. So the inside function being 3x squared plus x. So the derivative of 3x squared, bring the 2 down and it gets multiplied by the 3. So 6x to the first power, but we don't usually write that. Plus the derivative of x is 1. That's it. That's the derivative. What it looks like right now is we're taking the cosine of all of this, when really we're just taking the cosine of this. So I'm going to rewrite this derivative so that it doesn't look like that. I'm going to put 6x plus 1 first, and then the cosine of 3x squared plus x. And that's going to be my final answer. Okay, any questions? Everybody good? Juniors, y'all got it? Seriously though, if you have questions, feel free to email me. We'll get it figured out some way that I can help answer questions. Okay, but let's look at part B. We have a function f of t equals 2t cubed plus the cosine of t to the 50th power. All right, so outside function would be this raised to the 50th power, and then the inside function is what's inside the parentheses here. So to take the derivative, we do the derivative of the outside function, which would mean the 50 would come down in front. Inside the parentheses stays the same. And then the new exponent is 1 less, so 49. Then we multiply that by the derivative of the inside function. So 2t cubed is 6t squared. And then the derivative of cosine is negative sine. Okay, if you wanted to go ahead and do it in that step, you could. This plus a minus is just going to change that to subtraction. If you notice that as you're writing, you can go ahead and do it in that step. I did not do that, so I'm going to just make another step here. And that's it. That's the derivative of f of t. Okay, we got more parts to this example. Okay, part C. Y equals secant of 1 minus 5x. Okay, so outside function would be this secant function, and the inside is 1 minus 5x. So when we take the derivative, y prime, we take the derivative of the outside function. So the derivative of secant is actually secant times tangent. So this becomes secant of 1 minus 5x, tangent of 1 minus 5x. Then we have to take the derivative of 1 minus 5x, and that gets multiplied. The derivative of 1 is 0, and the derivative of negative 5x is negative 5. Okay, so then all that's left to do here is make sure that, like here again, it looks like we're taking the tangent of all of this, when really we're just taking the tangent of 1 minus 5x. So let's rewrite this as negative 5 first, then write our secant and tangent. That's it. Okay, part D. P of t equals cosine to the 4th of t plus cosine of t to the 4th. Okay, I don't think we've quite talked about this yet, so I'm going to rewrite this function. Cosine to the 4th of t, all that means is we're going to take cosine of t and then raise that to the 4th power. So those are the same thing. It's just usually written like cosine to the 4th of t. And then cosine of t to the fourth is fine like that. Okay, so we have a couple different chain rules going on in this function. We're going to have to use the chain rule twice, actually. So when we take the derivative of this function, just looking at this first part, the outside function is this raised to the fourth power, and the inside function is cosine. Okay, so the outside function would be 4 cosine of t to the third. And then we have to multiply that by the derivative of the inside function. So the derivative of the derivative of cosine is negative sine. So that's just the derivative of this first term. Now we can take the derivative of the second term. So this time the outside function is cosine, and the inside function is t to the fourth. Okay, so the derivative of cosine is negative sine of t to the fourth. And we multiply that by the derivative of t to the fourth, which would be 4t cubed. Okay, so then just simplifying this, we have 3 things being multiplied together here, and one of them is negative. So that means the whole thing is going to end up being negative. So we can write this as negative 4 times cosine of t cubed times sine of t. The same thing happens in the second one, 2 things being multiplied together, one of them is negative. So we can just say minus sine t to the fourth times 4t cubed. All right, we still have actually parts E and F to example 2. Part E is quite long, so if you're running out of room on your paper, I would suggest starting a new page. I'm actually going to go ahead and erase all of this too to give myself some room. Okay, part E. Y equals x cubed plus 4 all to the 5th power over 1 minus 2x squared cubed. Okay, so the first thing that we're going to have to use is the quotient rule. And then within that, we're going to end up using the chain rule a couple times as well. So the quotient rule is going to be enacted first, and then we'll have to use the chain rule as we go. So let's try. Let's remind ourselves of the chain rule. It is the derivative of the numerator. I don't know how to write that. Okay, so if we have f of x over g of x, the quotient rule is f prime of x times g of x, so the derivative of the numerator times the denominator, minus the numerator, f of x, times the derivative of the denominator over the denominator squared. That is the quotient rule. So we need to take the derivative of the numerator first, and the derivative of the numerator is a function within a function. So we have to use the chain rule to take the derivative of the numerator. So the derivative of the outside function. That 5 comes down in front. The inside function stays the same. The exponent has 1 subtracted from it. And then we multiply that by the derivative of the inside function, which would be 3x squared, and that's it. So that's the derivative of the numerator. And then we multiply that by the denominator, the original denominator, which would be 1 minus 2x squared cubed. All right, then we subtract the derivative, or no, not the derivative, the numerator as is, x cubed plus 4 to the 5th power, times the derivative of the denominator. And to take the derivative of the denominator, we've got to use the chain rule. So derivative of the outside function would be 3 times 1 minus 2x squared, and then we multiply that by the derivative of the inside function. The derivative of 1 is 0, and then the derivative of negative 2x squared would be negative 4x. Okay, all of that over the original denominator, 1 minus 2x squared cubed squared. Okay, so that is the derivative, but we're going to use some algebra to simplify the way that this looks. Okay, so stay with me here. This is my cat. Cool. All right, so simplifying this, y prime equals. Okay, looking at our numerator, there's this minus this. And I want to find any common factors and pull those out, factor those out. So we have x cubed plus 4. That's a common factor. And it shows up in this first set of terms 4 times. Whoops, because that exponent of 4. And then in the second term, it's 5 times. So the maximum amount of factors of x cubed plus 4 that we could pull out is 4. So we're going to do that. We're going to pull out x cubed plus 4 to the 4th. Okay, the other factor that they have in common is 1 minus 2x squared. And there's 3 of those in the first term, but only 2 in the second term. So we can only pull out 2. So we're factoring out 1 minus 2x squared squared. Okay, so what that's going to leave us with is, in the first term, we're left with 5, and then we got rid of those because we pulled them out, and then 3x squared, and we got rid of only 2 of these factors of 1 minus 2x squared. So we are left with 1 of those, 1 minus 2x squared to the first power, but if it's to the first power, we don't write it. Minus, we got rid of 4 out of these 5 factors of x cubed plus 4, so we're left with 1, x cubed plus 4, times 3. We got rid of both of these factors of 1 minus 2x squared, and then times negative 4x. All over 1 minus 2x squared to the 6th. Because when you raise a power to a power, you multiply. Okay, so it doesn't look like we simplified anything yet, but I promise it's going to simplify more than that from here going on. Okay, so right now we have 1 minus 2x squared in the numerator and 1 minus 2x squared in the denominator as factors. So they're all being multiplied. That means that we can get rid of these 2 that are in the numerator, and that's going to leave us with 4 in the denominator. And then as we do that, we're going to kind of simplify some of the stuff that's happening in the numerator as well. So we're still left with these x cubed plus 4 to the 4th. We got rid of those terms. They canceled out with some in the denominator. We didn't just like take them out. Okay, and then within the brackets, we can do some simplifying. 5 times 3x squared is going to give us 15x squared. And then we're going to distribute that to both of these terms. So 15x squared times 1 is 15x squared. And 15x squared times negative 2x squared is negative 30x to the 4th. Okay, we're going to do the same thing with this second part up here. Okay, so 3 times negative 4x is a negative 12x. And we're going to distribute that to both of these terms. So negative 12x times x cubed is negative 12x to the 4th. And negative 12x times positive 4 is negative 48x. Okay, that is all over 1 minus 2x squared to the 4th, because we canceled out 2 of those factors with the 2 that were in the numerator. Okay, let's combine like terms. Well, first we got to change. In the numerator, we got to deal with the signs that are happening. So we still have x cubed plus 4 to the 4th times 15x squared minus 30x to the 4th. And then we're going to distribute this negative. So this becomes plus 12x to the 4th plus 48x. The denominator stays the same. Now we have like terms in the numerator that we can combine. These x to the 4th terms, we can combine those. So we have y prime equals x cubed plus 4 to the 4th Actually, I'm going to write this up here. Okay, so I'm going to erase some of this stuff at the tops to give me some more room. Okay, we'll go with that for now. So combining those like terms, we would still have this x cubed plus 4 to the 4th times 15x squared. Why do I keep doing that? 15x squared, and then negative 30 plus 12 is negative 18 x to the 4th plus 48x. Okay, so I would be happy with this as your answer. If you would like to take it one step further, you can. So if you want to be an overachiever, the way that you could take it one step further is by looking at this set of parentheses. All of those three terms have a factor in common, and that is 3x. So we could actually factor out, we would still have that x cubed plus 4 to the fourth. And we could factor out a 3x, and that would leave us with 5x minus 6x cubed plus 16. All over and that would be my final answer for my derivative. Whew. This would be the time during class that I would take a brain break. But we just have one more part of example 2. So if you want to take a break, you can pause and do that. The last example isn't as long. It's still pretty okay, but this is the last one. Okay, so this is still example 2, and now we're at part F. We have a function h of t, and it is 2t plus 3 over 6 minus t squared. All of that raised to the third power. Okay, so in part E, we had to use the quotient rule, and then within the quotient rule, we had to use the chain rule. This one is similar, but kind of backwards. So this time we have to start with the chain rule, and then we'll end up using the quotient rule within the chain rule. Okay? So h prime of t, the derivative of the outside function which would be this exponent of 3. Taking the derivative, that means the 3 comes down in front. The inside function stays the same. And then 3 becomes 2. Okay, that's the derivative of the outside function. And then within the chain rule, we have to multiply by the derivative of the inside function. And the derivative of the inside function is going to cause us to have to use the quotient rule. So the quotient rule says the derivative of the numerator, 2t plus 3, the derivative of that is just 2, times the denominator as is, so 6 minus t squared, minus the numerator as is, so 2t plus 3, times the derivative of the denominator, which would be negative 2t, because the derivative of 6 is 0, and then the negative stays, take the derivative of t squared to get 2t. All of that over the original denominator, 6 minus t squared, squared. Okay, so let's simplify this as much as we can. It won't be as much as the last one, but in the numerator of this second fraction, we can do some simplifying. Good grief. So the first part is going to stay the same. There's not really much we can do to simplify this. All right, and then let's distribute this 2 to get 12 minus 2t squared. Jiffy, can you? Yeah. So 12 minus 2t squared. And then in the next one, we can distribute this negative 2t. So we get minus negative 4t squared minus 6t. Maybe I should have taken a break. My handwriting is getting worse and worse on this. Okay, last thing to do would just be to distribute this negative. If you want to do that within this step, that's fine. I did not, so I'm going to go ahead and just write a next step. The first part stays the same. And this fraction is 12 minus 2t squared plus 4t squared plus 6t. Okay, so then doing that, we can now combine like terms. We have a couple t squared terms that we can combine. I think this is going to be our last step here. Negative 2 plus 4 is positive 2t squared. All right, that's it. That's our derivative. Okay, so like I said, if you have questions, shoot me an email and I will answer as best I can. I'm going to set up a Zoom meeting for us at some point this week, probably later in the week, maybe Friday. So be checking your email for that invite. So this video, along with practice problems, is going to be posted on Google Classroom. So make sure that all of your friends that are in this class are in the Google Classroom. I sent out codes for that a few weeks ago. So just check on your friends, make sure they're getting their schoolwork, because it's not going to be fun if they wait around and try to do it all in a few weeks. That's not going to be fun. I hope you guys are doing well. I hate it for you seniors. This is not how I wanted the semester to go. Obviously, nobody wanted it this way. So I know that the school and the West Side community is going to honor you guys at some point, somehow, for graduation. We will figure out a way to do that. I know it's not going to be normal, but we will do it somehow the best we can, because we love you guys and we're proud of you. And yeah, I hope that you guys are staying safe and well. And if you need anything from me, please don't hesitate to contact me. Okay, bye.